The people love to draw in this way, so called a thread. Okay, so a thread, you can treat it as some people call it lightweight process. Some languages don't even have threadings. Okay, so what language you will find thread? In C, C++, Java. You won't find it in Python. You won't find it in Ruby. You won't find it in JavaScript. JavaScript point worker. What else? What are the languages you love to write? Don't tell me you write assembly.
Haskell.
Haskell. Sorry, Haskell is how can I say? It's not really a thread, but it allows you to do things in parallel, and also they decompose something so that they have a detection of the tail recursion, so and so forth. Yeah, well, this is some encryption between us. Okay. Yeah. So how about other languages?
Go.
Go. I don't know. Sorry. I should be friendly. Go should be friendly. As far as I remember, I never played Go, so I don't know. Any others? Huh? What? Oh, that I don't want to try. Okay. Yeah. So the threading part, actually, why I talk about the threading and ask you for experience. Okay, what is your languages you try? And as a matter of fact, threading has a high correlation between the scheduler. Okay. So the scheduler knows what is a thread, then you can launch a thread. If the scheduler don't know what is a thread, then it is not a thread. Later on, I will tell you why is it not behaving in something that the way that you don't understand or you don't expect. Okay? So this part is actually the aggregation of all previous 5 parts together. Okay? So you will find the schedulers coming up again. I will tell you how the kernel treat a thread so that we have something called native threads or non-native threads. Okay? And then we will have look at this table. This drawing, some boxes. So you will find a new box pop up. The orange guy from one split into 2. Okay. So this is just an illustration that each thread has its own storage. Okay. We call it the stack. Okay, or the local variable zone of that thread. And for other guys, the global variable, malloc, code, they are all shared, really shared, among the threads. So part 5, we talk about inter-process communication, is actually a preparation for this part. Okay, we will have all the problems of mutual exclusion, the race conditions, so on and so forth, all happen when these 2 guys wish to, let's say, they create a malloc variable. After the malloc, they want to use it together, we will have problem. Okay? So this is something that you will touch. Okay? And this is not only limited to C and C++. You can ask the teacher Java whether you will try thread or not. Then you will see many other keywords that I won't mention, like synchronize, notify, wait all. Okay, they are all for Java. And in C and C++, I choose to. Oh, I don't have the name here. Oh, sorry, I missed the name here. The name of the library that we will use is called POSIX threads. Okay. The POSIX thread, or we call it pre-thread. Okay, and there are other threading libraries. Intel has a for Intel CPU is called TBB. Okay, yeah, Intel threading building blocks. Okay, so you can choose to skip it because it's a system dependent thing. Okay, so the pthread library is for the language. This is not for the language, but for the CPU. Okay, so this is called TBB. And what is a thread? Actually, I didn't say anything about thread. Okay, first of all, it's not fork. Okay, fork is to create 2 separate memory zones. Now, I believe that you do your own assignment 1. Okay, then you understand that hey, after fork, the two processes have separate zone. When process 1 changes something, it won't touch any variables in process 2. Now, it is not the same case now. Whenever you create a new thread, it's just to create a new threading variables, local variables, but here they are shared, as well as they only execute the same code. See, they share the same code. So a threading program is not like a fork and execute paradigm. The fork and execute paradigm, you fork a new process and execute, change it into another program. Now you cannot do it. You only use the same code. And when you look at the usage, okay, the usage is actually to, but there's one goal, okay? The goal is, of course, parallel computing. I want to put one thread into one CPU core, another thread into another CPU core, so that they can run in parallel to give you parallel computation speed up. This is for speed. Another is a concern about the blocking calls. Whenever you are blocking calls like you read from keyboard, you read from network, and at the same time you want to compute something, okay, how can you do it? Usually you will set up different threads, okay? One thread is listen to the network, because when you listen to the network, you're blocked, right? Now think about it, while you're calling get X, F get S, scan F, can you do other things in parallel? No, you cannot. But with threading, we allow you to do so. You set up one thread to listen to the keyboard. Another thread is actually staying behind the screen, let's say do recording, whatever things you want to say. And at the same time, you can set up as many threads as possible. But there is a limit. Later on, I can teach you how to calculate the limit. Okay? Oh, if you are impatient, the limit is actually close to 8 megabyte divided by 4 KB. Okay, 8 megabyte divided by 4 KB, then around 300 something. Okay, you can create 300 something parallel threads. Okay, so later on I can tell you why we have this computation results. And this is the model, and the model is having a let's say having a keyboard or computation doing together. Now I have written a program to let you to see the result, and let's play for a while. Okay, so the code I don't want to show you because the code you can see the length of the code is quite long. Okay, so this is the game. Okay, wow. Okay, several hundreds. Okay, and then when I run it, okay, actually the several hundreds are hard code something, so it's already at 20 lines. Huh? So it's just a casino game, okay, big or small, okay. So let's try it out. Give you a preparation if you're playing this game, okay. It is there are two threads. One thread is doing the countdown, okay. So one thread is sleep for some time, another thread is listening to my keyboard input, okay. So if I am idle here, it will keep on countdown and say that timeout later. Hey, come on now, timeout, and then it will continue. So we have two threads together. Let's say I input something for this thread. Sorry, this is small. Small. Oh, I die. Sorry, I used up my life. Okay, I used up all life. Okay. This is small. Okay. This is big. Yeah, you tell me. I bet in computation. This big, this small, and then nothing. Wrong. I didn't count the case for it. All the same. Small, big. Okay, so it's over. Then you can play. Okay, and actually I have the two threads to play this game. Okay, and of course there is one more thread to do the drawing. Okay, so you can set up as many as possible. And some people already think that this is good, right? And actually this is not the only way to implement this game. You can have another computation like you use an alarm. Okay, you use a scanner together with alarm. That's also possible. But whenever you have a game that you need to do some countdown, okay, we better set up a thread. Okay, this thread, one thread doing countdown, one thread taking user input. Okay, and inside the threading program, so what we should set up, now we will talk about it. Now, first of all, you have to put all the functionality within one code. I said within one code doesn't mean one C code. You can have many C code, but I compile into one executable. Okay, compile into one executable, and we have some special things inside this program. You can see in these two boxes. We set up two so-called threading function. Okay, let's say I want to create two threads. I shouldn't say create two threads. I am the main, okay? While the main executing, I call the creation function twice, okay? To create two different threads. So at the same time, actually we have three threads. The main thread, the auxiliary thread A, and the auxiliary B, okay? And while they are computing together, actually we have a jail, okay? We have a box to contain that thread. We call it threading function. And that's why when you write this program, you have to set up functions that only for that thread to execute. So we have these two guys. Later on, I will tell you how to do it. And then while you're writing the code, you have to set up the memory. So the memory, we have 4 big zones, right? The code is actually one piece of memory. It is shared. The malloc memory, the global variable, they are all shared. Okay, so whenever it's set up a global variable, these two functions, while it is executing this new function, you can access variable, right? Every function can access global variable, and this global variable, you can access them without any control or with some control. Okay, so without any control, that means that the normal way, yeah, you have a global variable called ABC. Okay, then you try to change the ABC value, or you use a mutex protection over that variable. Before you access it, you lock it up, and then you access it, and then you release the lock. Okay, it's up to you. You can code it in the wrong way, okay, or you code it in a good way in order to avoid the race condition. So these two guys race condition. Now the third is the local variable. So every thread has its own set of memory. We call it you can call it a thread zone, or I shouldn't call it thread zone. I just call it a local variable, because later on you will see some strange behavior over there. Okay. Now how to write it? Very simple. Let me show you the code now. Very, very simple. So I have so many codes here, and this is a start with hello world, of course. So this hello world is not a normal hello world. I insert some computation within this hello world so that you can see they are actually running something in parallel. And look at the main first. The main, except these two lines, you don't understand. Other than these two lines, you all understand this, right? I just have a main. The main will do a loop, and while it is doing the counting, reach certain milestone, they will keep printing things, and by the end of it, it will reach return 0. Okay? So the extra things will be the prefect call. So what are the prefect? Remember the post-fect library. So what are the things inside? We can find the counterpart for processes. Okay? So what are the counterparts? When you want to create a process, you call fork. Now you don't call fork. You will call prefect creates. Okay, create a thread within that process. And when you finish that fork, you will create a new process with a new PID. Now it don't give you a new PID, but in other stuff, we call it a thread structure. This is a structure. Yeah, don't print it out, okay? Although you can print a number, but it's a pointer value, okay? So there's a structure, and the structure is of this type, prefect underscore key. And when you want to query whether you are a specific PID or not, you will use get PID. Now it's not get PID in the prefect, it's called prefect self, and returns you the structure. The structure. So we have other guys here, prefect exit. Wait and wait PID is become prefect join. Okay, so why it's called prefect join? It's very interesting. Yeah, I forgot to bring my whiteboard. Okay, so I have to use something ugly. Okay, then all right. Let me stop this guy. So why is called fork? Why is called join? Sorry. Actually, the diagram, when we draw a thread, usually we will start with this is the main, and then I say that, oh, we create 2 threads, 1 thread, 2 threads, okay, and when they finish, okay, they will join back together, okay, so this location is a join. Just like the GitHub diagram, it's something, oh, GitHub, we want to merge, okay? Then it becomes something here. Now this is not called merge in Pthread, it's called join, okay? So let me remove this ugly diagram. Maybe you don't know, okay? My art subject is always fail, okay? So last we can queue a thread, okay? So using the Pthread queue. So you can find all things, but how to program it? Very simple. Create a thread function. And the thread function has a special signature. The signature is you should return a pointer or void. Interesting, huh? That means what? That means, how many of you don't know what is void pointer? Yeah, because quite a number of you is taught by me, and I didn't talk about void pointer. Okay, void is a data type of nothing, right? And what is void pointer? Void pointer, we call it generic pointer. Generic pointer means that you can use the void pointer to cast it, okay, become an integer pointer, become a float pointer, become a char pointer. So we usually call it generic pointer. It means that this function expects you to return anything, just anything. So we call it generic pointer. And this generic pointer is the return values, although I miss it, okay, but well, actually we don't need it, because this just print out hello world, we don't return anything. And the signature, not finished yet, return our generic pointer and accept a generic pointer. So what is the meaning of accept a generic pointer? You can parameterize a thread function, okay? So you create a thread function, you want to give it a parameter. You can use the structure or use a string. In this example, I create a string, okay? During the call of the creation, I kind of pass this pointer in. So the library design is like this. It don't care what is the data type, no matter it is a string, no matter it is a structure, an array, because it's generic pointer. So you can cast it back to a char pointer. Okay, so this is usually the C programming is like that. Okay, and people get lost starting from this slide onwards. Okay, word pointer. Okay, yeah, word pointer is just you can treat it as just to me it's just a 4 bytes in 32-bit CPU. A pointer is a 4-byte address. Okay, and in 64-bit CPU it's an 8-byte address. That's all. Okay, and in the creation part is not difficult. First, you create it's very different from the fork. Okay, fork we don't have any parameter. Now the creation is you put down a structure, and it will use pass by reference to update it. Okay, so you have to pass a pointer to it. And here is a special control. You can control the thread in different ways. Okay, so if you want to know more about this, I recommend you to have this book. Although in this course we won't use this second variable. The book is called Post-Thread Programming. Okay, PDF, sorry, not PDF, already. Okay, image. Yeah, this one. Okay, this is a very good book. Okay, talking about all the parameter of the second input of the function creates. Then you will put down the name of the threading function with the signature void star, and here is void star, and you can parameterize it by passing in a string or whatever things you want. That's it. That's it. And here is the Pthread join, and which is the same as wait PID. Wait PID, you give a PID inside. Now this is not a PID, just a structure of the thread. So when you execute it, what will happen? Pthread hello. So you will see the main thread and the auxiliary thread, or I will call it child thread. it will execute together in parallel. Okay. So inside the code, what I'm doing is more than this example code. I'm doing something like this. I create a thread, and when it's created, just like for, it will run in parallel with you. So during the time after the creation, I will ask the main thread to execute something busy, and also execute something busy inside the hello thread or the child thread. Then after it, I will terminate the thread by using prefetch exit. All right. But before I terminate it, I will also make use of the input so that you know that I can successfully pass in the input to the thread. Okay. So you will see the result will be a hello world here. A hello world here. Okay. So you can, I think this is quite straightforward. So you can change it into bye bye. Okay. Yeah, bye bye. Yeah. Yeah, then it will become bye-bye, right? So if you will see this is very easily to create something work together. Okay? So I already said that you can use a global variable. Okay? So how about I pass in a global variable, I set up global variable called global. Okay? A global integer. Okay? Equal to this is not interesting. Okay? Equal to haha. Okay? Then how about I also print out the global here? This is here. Oh no, haha. It's the global. All right. So I can set up a global variable equal to haha. Then let's see. So you can see it's appear here. So you can understand now the main thread actually execute at the same time with the child thread. And at the same time, you can also share something. Let's say the global variable here, but I didn't share anything, right? Let's try. I didn't share anything, so I can set up after the creation. I change the global equal to hi hi. Okay, from haha to hi hi. What will happen? Then it will, it will become hi hi here. All right. So then you can try by yourself some hee hee ha ha whatever things you want to try. Okay. Then you understand what happened, right? The main thread can actually touch the global variable. The child thread also touch the global variable. It's the same case for parallel. So they are sharing things very easily. Now think about it. All the things that I talked about in part 5 kicks in. Okay. You need multi, you need IPC support, you need a producer-consumer model, so on and so forth. Okay, so that's why some people really hate when let's say you go to work, okay, your boss tell you that this program is going to be multi-threading, then you suddenly start multi-threading. No, I don't want to touch producer-consumer again. Yeah, but you can avoid. All right, so this is just illustration. Some illustration here. I talk about, I forgot about the join. The join is a wait, okay? So you will wait for the hello thread to terminate, and this is targets that you will wait for. So just like wait PID. No problem. Very easy, Any problem you want to ask? Anything you want me to try? Anything you want me to try? No? Huh?
How to pass multiple variables?
Cannot. You have to pack it in as a structure. Pack a structure, then you can pass multiple things. Yes? Which one don't exist? No thread exists? So I've asked for whether you say that it is allow the main thread to wait or not wait. We wait, but the child thread don't terminate, even alone. Even alone. Yeah. So, but if the main thread terminates, then it will terminate the whole program because the main thread eventually reaches exit. Then it will kill both threads. Anything you want me to try? No? All right. Then I ask you something. Okay. Yeah. Use your imagination to answer me what happened here. So let's take a look here. This program. This program is a kind of not funny. Okay? Why is not funny? You say, huh? Okay, yeah. Take a look here. I want to pass in the integer variable from the thread main to the thread do your job. Okay? So actually we have two threads. And the main thread set it up with the variable input equal to 10. Because I said that we can go through the generic pointer. So I just put the address of input here inside the pre-thread create call. I hope that I will pass this value to the thread called do a job. Okay? So far so good, huh? I pass in the thing here. I make sure that it is correct. So I print out main into the input. I should get 10. All right. So inside the child, what should child do? Of course, you can read it out by dereferencing the pointer, right? I dereference the pointer. Now here is kind of a, if you're not comfortable with pointer, then you will want to vomit, okay? Yeah, it's a first you cast it from a generic pointer back to its type, because you code the program so you know its type to the integer pointer, then immediately you dereference it. Okay, you cast it and immediately dereference it, you print it out. Then you want to update its value. So I also set up something ugly. Again, I cast it to the type of integer pointer, then I dereference it so that this is an integer, and I update it with 20. And let's take a look. When I run it here, I change a bit so that the program become a little bit funny. The update part, I make it become a random call. Okay, just random with some max. Okay, the max is 100. Okay, and everything is just the same. Start with 10 here, start with 10, and then pass it inside. It will change. Compile it. Okay, call it evil. So because it's a very evil program. Okay, so it's up to date. Run. So initially, this 10, when you pass in, it becomes 10 while you're doing the referencing, and you update it, it becomes 7. So far, so good. But after you update it, and the thread will terminate. Okay? And after termination, we will come back from here because you have a join here. Okay, you have a join here. Then you will get the final input value being changed. I hope that you get an idea of this program is using a lot of pointers, dereferencing, is kind of violating the first idea that I give you. What is the first idea I give you? The first idea is this diagram, the page 1 diagram. Okay? The two threads set up two local zone. Okay? Why does two local zone? Okay? I don't know whether you understand this. Okay? This variable is actually a local variable to this function. Okay? So when this function dies, this local variable also dies. So I treat it as a local variable. So this is a local zone of a new thread. This is also the local zone of this main thread. Anything you don't understand except that it affects, okay? Every syntax thing you understand, right? Yeah, all the grammar things, all the dereferencing things you understand. Then I will go to the reason. Okay, and after the reason, I will give you another program, and then I will dismiss the class. I expect that I will receive some answer on Thursday. So, the problem here is, threading is something that really hard to code because it makes too many concepts together. Now, first of all, I will first mix the concept. What is the real meaning of separating the two local variables off? Okay, so this is the first confusion. The confusion starts with here. You create a local variable called input. I give it a blue box there. It really contains a value. And then I pass it into the prefix create, but actually I didn't create anything, right? I pass in a pointer. You understand that I pass in a pointer means doesn't create anything. You understand this concept? Yeah, if you don't understand this concept, raise up your hand, okay? I will give you tutorials, okay? You didn't create anything, okay? So you just pass in a pointer address to this function. And this function actually create another box, this red box. The red box is not containing any storage for the number. It's actually the storage for the address. Okay? It's a storage for the address so that this red box is not actually holding any value. It is an address pointing back to this location. Okay? Now makes this concept very clear. You are passing an address, and the address just copied this location. That's why you are pointing, so happen is the same guy. Okay? Any confusion here? Yeah. For me, it's just like that. Just not confusion. It's very straightforward. Yeah. Yeah, straightforward. A pointer is pointing something, and then yeah. Okay, so this is the first milestone that I hope that you will understand this. It is done through pointer passing. It's not passing its real value. So that's why when you try to use this pointer address to update this variable as if you're updating the blue guy. Okay, the red guy is just an address. So you may ask the question, hey, you said that you are separating the two songs. Sorry, we didn't create any variable. And no extra variable in your thread. No extra storage in your thread to store that input. So the solution to tackle this problem is actually very simple. To tackle this problem, I said that you didn't create any storage for that particular variable. Then you should create it. Input, I call it backup. Okay? Backup equal to the referencing pointer. Okay? Yeah. It's just automatically give me one more. Okay? So you should back it up before you use it. Okay? Remember this. You have to back up that variable, and then after you back up this variable, no matter what you change over this backup, you won't change the outside environment. So this is a very common mistake for beginners to write threading. Now, with this in mind, do you have any question? If you don't have any questions, then I give you the next program. The next program is very interesting. Very interesting. Okay? So what is the next program? The next program is, okay, I use the main to create 5 different threads with the same threading function, but with different inputs. Okay? So I pass in different inputs. This is the I variable. I use the I variable pointer address, the address, not pointer address. The address pass into the creates, and then I back it up immediately when I start the thread. Okay? So I follow my solution suggestion and continue to create more threads. And what's next? I will wait for them one by one. Just like what you have done in assignment 1, right? We create a pipeline, then you call wait PID over each PID. I do the same. I create 5 threads, I wait for those 5 threads. So what should I expect? I expect I will find my ID number equal to 0, 1, 2, 3, 4. Okay? Then what is so special about this program? Beautiful. 2, okay, execute. Any problem? One more time. One more time. Hey? Why? Oh, yeah, this is another combination. Great. I try sometimes it will get all the same. Let me try. Will it be all the same? Hey, come on. Give me something. It's this is better. Right. Yeah, this is better. 3, 3, 3, 4, 5. Interesting. Yeah, very interesting. Huh? I expect that you will try this program out. Okay. Yeah, because although this course may not use Pthread, but other course will. When you write Java, you use Pthread. When you write C++, GUI control, you use Pthread. Okay. When you do some countdown operation, you use Pthread. Make sure you understand what happened here. I expect some answer on the coming Thursday lesson. Okay. Although I already give out the solution is here, but actually you don't know what the solution is doing. Okay, without my explanation. All right. So this is a very important point. Then we will continue to talk about